Good afternoon, student. Let me discuss some more questions on the continuity of a function at a. Now the question is here: for what value of lambda is the given function is continuous at x equal to 0? What about its continuity at x equal to 1? Let us see the question. Now the function is defined differently for different interval. When x is less than equal to 0, function is this. When x is greater than 0, the function is this. Now at x equal to 0, left hand limit x tends to 0 minus fx equal to limit x tends to 0 minus means x is less than 0. Then the function is lambda into x square minus 2x. Putting x equal to 0, we are getting this is equal to 0. Then we again find out the right hand limit. Limit x tends to 0 plus fx. Limit x tends to 0, 0 plus our function is 4x plus 1. Then this is equal to, by putting x equal to 0, we are getting here right hand limit is equal to 1. Now the left hand limit is not equal to right hand limit. Therefore the limit does not exist. Therefore we can write no value of lambda make it continuous. Now here again we have to check its continuity at x equal to 1. Now again we will find out the left hand limit x tends to 1, fx limit x tends to 1 when x, it means x tends to 1. Now when x is greater than 0, our function is 4x plus 1. So therefore limit x tends to 1, 4x plus 1. Then putting x equal to 1, you are getting this is equal to 5. Now here limit of the function is equal to 5 and also the value of the function is again because x is greater than 0, it is equal to 4x plus 1. Therefore for f of 1 is again equal to 5. Now here the limit of the function is equal to value of the function, so we can say the function is continuous at x equal to 1 for all values of lambda, because this expression does not depend upon the lambda, only the above depend upon lambda. When we are getting finding the limit at x equal to 0, we are getting the left hand limit is not equal to right hand limit. Limit does not exist, therefore no value of lambda can make it continuous. But for all x greater than 0, we will find as at x equal to 1, it is what? Greater than 0. We will find out the limit of the function is 5 and also the value of the function is 5. So we can say the function is continuous at x equal to 1 for all values of lambda. Now see the another question. We have to find out the value of k for which the given function is continuous at x equal to 0. Now the given function is given to be continuous. It means left hand limit equal to right hand limit equal to value of the function. Now at x equal to 0, first we will find out the left hand limit. Limit x tends to 0 minus fx. Limit x tends to 0 minus. Put the value of the function here, k into sine pi by 2 into x plus 1. Now putting x equal to 0, we are getting here k into sine pi by 2 into 0 plus 1. K into sine pi by 2. As sine pi by 2 is 1, this is equal to k. Now the left hand limit is coming equal to k. Now again the right hand limit x tends to 0 plus fx. Putting the value of the function here, tan x minus sin x upon x cube. Now for this function we have to find out the limit. Now the same question is there in the 11th class also. When you find out the limit, we are just converting it here. Tan x can be written as sin x upon cos x minus sin x as it is, x cube as it is. Then simplifying the expression, we are having sin x into 1 minus cos x upon x cube. It can be written as limit x tends to 0 plus sin x. Now 1 minus cos x can be written as 2 sin square x by 2. Now this x cube can be adjusted like this. One x will be here and another x square will be here. Now making the same angle in the numerator and denominator by multiplying and dividing by 4. Now by taking the limit, this can be written as, now again sin x upon x is 1, 2 as it is, 4 as it is, again sin theta by theta is equal to 1. Putting all these values, we are getting the right hand limit equal to 1 by 2. Now again the function is given to be continuous. Therefore we must have left hand limit equal to right hand limit. Therefore the value of k must be equal to 1 by 2. This we have to find out. Let us see another question. Now the question is, you have to find out the value of a, b, c for which the function is given to be continuous at x equal to 0. There are three unknown quantities we have to find out. Now the function is continuous at x equal to 0. First we find out the left hand limit. Limit x tends to 0, 0 minus fx, putting the value of the function when x is less than equal to 0. Now how to find out the limit of the function? Again, this question is there in the 11th class. Now by separating these two terms, it can be written like this: sin a plus 1 into x upon x plus sin x upon x. Now by again taking the limit, making the angle same in the numerator or the denominator, it can be written as what? Multiplying and dividing by the expression a plus 1 here. And again it can also be written limit x tends to 0 sin x upon x by separating the function. Now here it is again sin theta by theta is 1. 1 into a plus 1 plus again sin theta by theta is 1 plus 1. So we are getting the left hand limit equal to a plus 2. Similarly, for finding the right hand limit, limit x tends to 0 plus fx, limit x tends to 0 plus, the expression is this. Now it can be written as here, by taking from the numerator, we have taken under root x common from both the expression. Easily we can take under root x common from both the expression. Now under root x is common. We left with here 1 plus bx minus 1 upon b into x 3 by 2 as it is. Is it clear? The main point is here, from both the expression we are taking under root x common. Now here when you take it common and collecting the terms, it is what? Under root 1 plus bx minus 1. In the denominator b, x raised to power 3 by 2. Just this under root x can be taken in the denominator by collecting the same terms. The power should be subtracted. So it can be written as b into x 3 by 2 minus 1 by 2. So it becomes here, and it becomes b into x. Now again here rationalizing the numerator, it can be written as under root 1 plus bx plus 1 upon under root 1 plus bx plus 1, because when the function is irrational, either in the numerator or the denominator, always we have to rationalize the function. Now simplifying it here, it is 1 plus bx minus 1. Now here this can be written as b into 3 by 2 minus 1 by 2 1. It can be written as x, and this expression as it is. Now taking limits also, x tends to 0. Now the common term will be cancelled, x cancelled with x and b cancelled with b. Now the taking limit x equal to 0, when we put x equal to 0, it becomes 1 upon under root 1 plus, because b is 0, under root 1 plus 1, it is equal to 1 by 2. Now the left hand limit is a plus 2, right hand limit is 1 by 2. And the value of the function, it is given in the question, what? When x equal to 0, it is given to be c. It means all these three should be equal. So we can write the function is given to be continuous. So we can write the left hand limit equal to right hand limit equal to value of the function. So it is a plus 2 equal to 1 by 2 equal to c. Simplifying these two, we are getting here c equal to 1 by 2. By simplifying these two, we are getting a equal to minus 3 by 2. Now this expression is independent of b. It means b can have any value. But here the b is in the denominator, and denominator can never be 0. Therefore we can write a equal to minus 3 by 2, c is 1 by 2. B can have any value except 0. It means b cannot be 0. Now let us see the question depending on the modulus. This function is given like this. Check its continuity at x equal to 2. Now the function is in the form of the modulus function. We will find out the left hand limit and the right hand limit. For the left hand limit, we have to put x equal to 2 minus h. Left hand limit, limit x tends to 2 minus mod of x minus 2 upon 2 minus x. Putting x equal to 2 minus h. Limit h tends to 0. Putting x 2 minus h like this. Simplifying, we are getting here limit h tends to 0 mod of minus h upon h. So therefore it becomes modulus of minus h is h. this as it is, this is equal to 1. So left hand limit is equal to 1. To find out the right hand limit, putting x equal to 2 plus h. Limit h tends to 0, 2 plus h minus 2 upon 2 minus 2 plus h. Again simplifying, we are getting limit h tends to 0, mod of h upon minus h. Again modulus of h is h, h upon minus h equal to minus 1. So therefore we are getting here, we have to check the continuity. Left hand limit is 1 and right hand limit is minus 1. Left hand limit is not equal to right hand limit, so we can say limit does not exist. Therefore the function is discontinuous at x equal to 2. Now here the next question is based on the greatest integer function. This is the sign of greatest integer. Now you have to check the continuity of this function at x equal to 1. Again the function is, first we will find out the value of the function. Value of the function f of 1, putting x equal to 1, 1 minus 1, 1 minus 1. Now the greatest integer of 0 plus greatest integer of 0. 0 is itself integer. Its greatest integer will be 0. 0 plus 0 equal to 0. Therefore value of the function is equal to 0. Now we find out the left hand limit. Limit x tends to 1 minus greatest integer 1 minus x plus greatest integer x minus 1. To find out the left hand limit, we have to put x equal to 1 minus h. Putting x equal to 1 minus h in both here and simplifying here, we are getting limit h tends to 0, greatest integer of h plus greatest integer of minus h. Now this point, see this point very much carefully. Now h is a very small positive quantity. It means x lies between 0 and 1. If the number is lying between 0 and 1, so its greatest integer will be 0. Now here it is greatest integer of minus h. Now this value lies between minus 1 to 0 and its greatest integer will be minus 1 because all the integer lying on the left hand side and the greatest one, that is the definition of what? Greatest integer function. So therefore the greatest integer of minus h, because now this quantity lying here, its greatest integer will be minus 1. 0 minus 1 is equal to minus 1. So therefore left hand limit is equal to minus 1. Again we will find out the right hand limit, putting x equal to 1 plus h. Putting x equal to 1 plus h, simplifying again we are here, limit h tends to 0, the greatest integer of minus h plus greatest integer of h. Again the greatest integer of minus h is minus 1 and greatest integer of this h is 0. It is equal to again minus 1. Now the left hand limit is equal to right hand limit, but well, it is not equal to the value of the function. So again we can say the function is discontinuous at x equal to 0. This is the way how to do the question of the greatest integer function. This is the sign of greatest integer. Now let us see the question. Again the question is here. We have to find out k, for which the function is given and function is continuous at x equal to minus pi by 6. Now let us see the solution. Now limit x function, when x is not equal to minus pi by 6, the function is this. Either it may be left hand limit, it may be right hand limit, the function value of the function remain this. Now directly we are finding limit x tends to minus pi by 6 fx, putting limit x tends to minus pi by 6, putting the value of the function. Now here in the 11th class we have done this question. Whenever any trigonometrical function is given and we have to find out the limit of the function, first we have to make the limit 0. To make the limit 0, we will put x equal to minus pi by 6 plus h. The value, whichever value of the limit is given, we have to put x equal to minus pi by 6 plus h, because we have to make this limit equal to 0 when the limit of trigonometrical function have to find out. Putting x equal to minus pi by 6 plus h, you can also put minus pi by 6 minus h can also be put. But generally we are putting x equal to minus pi by 6 plus h. Now as x tends to minus pi by 6, h tends to 0. Taking limit h tends to 0, putting the value of x here. Then simplifying the expression using the result sin a minus b and cos a minus b. Now sin A minus B is what? Sin A cos B minus cos A sin B. Cos A minus B is cos A cos B plus sin A sin B. Putting upon H like this. Now here putting the value of cos pi by 6 and sin pi by 6 in the expression. Putting the values here. Sin H cos as it is. Again when you simplifying it, the common term will be cancelled out. And we left with, by simplifying, you are getting here 3 by 2 sin h plus 1 by 2 sin h. So it will be 2 sin h upon h. When you take the limits, it is 2 into 1 equal to 2. Therefore, the function limit of the function is equal to 2. And also in the question, let us see, sorry, we have to find out the value of k. The function is given to be continuous. We have to find out the value of k. Now we'll find out the limit of the function, and it is equal to, it is coming equal to what? So it is equal to 2. Therefore, the function is continuous at x equal to minus pi by 6. Therefore, the limit of the function must be equal to the value of the function. So we can write k equal to 2. Always this type of questions are very much important in the examination point of view. This is all about today. We will try the question from the